Welcome to Pomodoro Joe for Saturday, July 8th, 2023. Today we're looking at LeetCode problem 2551, put marbles in bags. This is a hard problem. All right, we are given k bags and a zero-indexed integer array, weights, where weights at index I is the weight of the ith marble. You are also given the integer k, which they already told us, so blah, blah, blah. Divide the marbles into the k bags according to the following rules. No bag may be empty. If the ith marble and the jth marble are in a bag, then all the marbles in between the I and jth marble are also in the bag. If a bag consists of marbles with an index I to j inclusive, then the cost of the bag is the weights at index I plus the weights at index j. The score after distributing the marbles to all the bags is the sum of the costs of all the bags. Return the difference between the maximum and minimum scores among the marble distributions. All right, so we are given some marbles represented by this weights array. We have to divide all these marbles into k bags. Every bag has to have at least one marble. Now the rules of distributing these marbles say that if we include 2 marbles in any given bag, then we also have to include all the marbles in between those 2 marbles. So this array is ordered, and if we choose 2 marbles to put in a bag, all the marbles between those 2 marbles also have to be in that same bag. And the cost of every bag is just the cost or the weight of the end marbles. So the first marble and the last marble in that bag. Now our score is the total cost of all the bags. So we divide all of the marbles up into all our bags, calculate the cost for each bag, then we sum those costs, and that is our score for that distribution. Now our goal is to find the maximum score possible for all the distributions and the minimum score possible for all the distributions and return the difference. So the maximum score minus the minimum score. So this problem isn't all that bad. It's just going to take a little bit of analysis before we jump in and start coding. So let's break this down into the simplest version of this problem. We have some array of marbles and we only have one bag. So k is 1. So let's say we have start with marble A and we end with marble B. And we have a bunch of marbles in between. So we only have one bag. All the marbles have to go in this bag. So our score for this one, well, so the cost for the bag is just A plus B. And the score for this distribution is just this one cost. So that's just A plus B as well. And now our result is just the difference between the maximum score and the minimum score. In this case, the maximum score and the minimum score are the same because there's only one bag, there's only one score. So our result in this case is 0. Okay, so that's like the simplest version of this problem. We have any number of elements, but we only have one bag. So let me put that here. K is equal to 1. All right, so that's pretty straightforward. What happens if we have 2 bags? Now k is equal to 2. Well, I'll just copy this here. Let me do this. All right, now we have k equal to 2. We can't just put them all into one bag. We need to have some dividing point. So at some point in our array of marbles, we have to have a dividing point where everything to the left of that point goes into one bag and everything to the right of that point goes into another bag. So at this point, we can kind of divide this into 2 bags. We have A, and then that leads to some, I won't call this B because we already have B, so I'll call this C. There we go. And then we have D, and that leads to B. All right, so we've divided our marbles into 2 bags. One bag is A and C, and all the marbles in between, and the other bag is D to B and all the marbles in between. So what are the scores here? Let's see. We have 2 costs now. We have cost AC, and that's just A plus C. We also have cost DB, and that's just the cost of D plus B. All right, now our score is just the sum of these costs. So that's really A plus C plus D plus B. So we basically just sum all of these marbles together. Now we have two scores that we'd care about, the min score and the max score. So basically we can slide this point along somewhere in here. So we can just slide this point around, find these different pairings, find a maximum of these pairings, and then find a minimum of these pairings. So A plus C plus D plus B. Anyway, we find the maximum sum here, and we find the minimum sum just by moving this point around. Now when we move this point, all we're really doing is moving where in our array we grabbed our C and our D. Our A and our B don't change at all. So we can actually ignore A and B. We can just look at this pairing, C and D. So we grab some point in our array. We look immediately to the left of that point, find that value. We look immediately to the right of that point and find that value. Now that pairing will just represent the sum that's different between that pairing and some other pairing, because our A and our B don't change at all. So our C and our D are the only things changing. So we can just slide this point around, try to maximize our C plus D, and then also slide it around, try to minimize our C plus D. Then we calculate the delta between the two. So we really only need to go through this array once from start to finish, finding this pair where we have our split point. When we find the pair that's maximized, we keep track of that. When we find the pair that's minimized, we keep track of that. Then our result will just be the maximum minus our minimum. So that explains how we do k equals 2. What about k equals 3? Well, at that point, we basically have another split somewhere. So we still find the maximum and minimum splits, but then we'll find a second split. And this will be whatever we want to call it, E and F. So we can keep going through and finding these different splits. So how many of these splits do we need to find? Well, with k equal to 1, we find 0 splits. When k is equal to 2, we only need to find one split point and have the min and max of that one split point. When k is equal to 3, we have to find 2 split points, because as you can see, that divides us into 1, 2, 3 bags. So we basically need to find k minus 1 of these split points. And these split points will always be right next to each other. So this is actually pretty straightforward. Let's put 25 minutes on the Pomodoro timer and get started. So for this, we just need to keep track of all of our split points. All right. Now we need to go through our array and calculate all of these pairings of our split points. So for every index and range, we'll go from range 1, because we don't want to start at 0. We'll be looking back at the previous split point. Actually, we can start at 0. Why not? Let's start at 0. So we'll go from range 0 to length of our weights minus 1. Because we'll be looking ahead by one element, we don't want to go out of bounds. So our pair here, or our point value, what do we call this? Split cost? I'll do that, yeah. That'll just be equal to the weight at this index plus the weight at the next index. All right, and we'll just add this to our split points here. Okay, so we go through, we calculate all the possible split point costs. Now we know how much it's going to cost at any given split point. So now that we've calculated all of our possible split point costs, we want to minimize our score and maximize our score, and then find the difference between those two. So the min score, let's see, how are we going to do this? Well, the easiest way to do this is just to sort our split points. So let's do that. So this will sort from low to high. So our minimum values will be at the beginning of this. So our min cost, or I call it min score. So the min score will just be the first k minus 1 of these split points. So that's just going to be the sum of our sorted split points. All right, my copy and paste doesn't work, so I'm going to have to just type this out. So this will be the sum of our sorted split points up to k minus 1. Because remember, if we have one bag, then we have 0 split points. If we have 2 bags, we have 1 split point. So we have k minus 1 of these split points. Now our max score, well, this is going to be at the other end of our sorted split points here. So that'll be the sum of our sorted split points. And now we need to get the last k minus 1 elements. So this will be k minus 1 negative k minus 1 to the end. All right. And now we just return the result, which is our max score minus our min score. Now, the only thing I'm a little bit worried about is this. I'm not 100% sure this is right. Let's say k is equal to 1. If we do a negative 0, that might not work out the way we expect it to. So let's do this a little bit differently. So we'll take the length of weights minus 1 to get the last index, and then we'll subtract k minus 1, and we'll take that to the end. So this will be the length of weights minus k minus 2 to the end. All right, let's see if this works. Oh, man. All right, let's do a quick pass and make sure that we've got everything here. Split points for index and range of weights. All right, we need to grab the weights at this index and the weights of index plus 1. We append that to our split points. All right, let's give it a try. And we are way off. Let's see what's going on here. Let's say if k is 1, this will be from 0 to 0. Okay, if k is 2, this will be from 0 to 1. That should be all right. All right, what about this guy? It should be length of weights minus k minus 2. There we go. Or length of, okay, this is wrong. It should be length of weights minus 1 to get the last index minus k minus 1 to the end. So that's just length of weights minus k. Yep, that's what it should have been. There we go. All right, sorry for this. This was pretty terrible. Let's submit this, see how we do. And we pass. And we do okay. We beat 78% for runtime and 44% for memory, so that's not too bad. We could jump back here and do a couple quick things. Let's do this. So we only have to call length of weights once. Let's do that. So this will go to the max index. And this one, I guess we'll have to add one here. That's all right. Let's see if this makes a difference. Not really. We had a 78% before, and now we have a 70%, so it didn't really make much difference. In fact, it made things worse, so I wouldn't necessarily recommend doing that change. Well, I think that's the best I've got today. So that's it for me with a 77% for runtime and a 44% for memory. Hope this made sense. Hope you enjoyed this. Hope you learned something. Hope you had fun. Hope you can go out and write better code.